Very good morning to all. So this is Chandra Kumar, Assistant Professor, Department of Mechanical and Tamil Nadu College of Engineering and Technology. Today I want to discuss about the general topic of light sensors. So what is a sensor? First of all, we want to know what is a sensor. So sensor is a device which produces a proportional output signal like mechanical, electrical, magnetic waves, etc. when exposed to the physical phenomena such as pressure, temperature, displacement, force, etc. So what is mean the physical phenomena and what is mean by the signals? So the physical phenomena, how much pressure will be available in that component or how much light intensity is available in the outdoor area. So it is a measuring one, it's a physical phenomena we want to measure and we want to sense. So for that sensing purpose we are using sensors. So whatever may be the input signal they can receive, it gives us an output. So first of all we want to know about the light sensor. So sensor working we are all clearly discussed. So light sensors. So light sensor converts a radiant power. So wherever the light is available, if you are using that light sensor, it can easily convert and it can absorb that wavelength and it can use as a. So the light absorbs, they can changes in the resistance or current or voltage. So digitalization takes place. What is meant by digitalization? They can be converted as analog into digital form. So it's known as a digitalization. They have a light sensors can be categorized as a photoresistors, photodiode, and phototransistors. So we want to see one by one. So photodiode. So the rate of generation of electrons. So in the photodiode, the rate of generation of electrons, it absorption of electron results in a free charge. The electrical conductivity is also increased at the time of observing the electrons. The PN junction fabricated from the semiconductor material. From the diagram, we watered with the doped N type of silicon. So this is the diagram. First of all, we want to see with the diagram. So the diagram consists of a N type of silicon diode. So it's a N plus is a downwards and depletion region. They have a positive region and they have an insulated coating. And above that, they have a metal contact. They have an incident light enters into the photodiode. It gives us a negative charge, and they have a positively charged. It can use as the output from this area 1 and 2. So PN junction is created. The radiation passed on the electron hole pair is generated and then neutralized. So the diagram shows that concept. Then phototransistors, the light sensitivity collector based on the PN junction diode. So this is a phototransistor. Whenever the light incident will receives in the PN junction diode, at that time the output voltage will be generated. So the output voltage is gives as input for the sensor and it gives us a reading and it can sense us and it can be reacted wherever maybe the circuit is connected. So when the light rays pass to the circuit, the light can be converted into the current. So light rays pass to the circuit, it gives us output voltage, so it can be converted as a current. So it is a reverse process of light from the voltage. So it's a very good reverse process as compared light compared to the voltage. So light voltage is given, the light will be low. So here the reverse process, light will be given the power to the circuit, it can be converted as a voltage. So it is a reverse process. Then photoresistors. So it is a semiconducting material, phases of electrodes. So it is a photoresistor. So it is a semiconducting material, phases on electrodes. So cambrium sulfate used as a detector. Here the detector can be used as a material is cambrium sulfate. So in the detector, so other photoconductive material lead sulfate and mercurium cadmium telluride. So it is increase in light sensitivity of photoresistor, decrease the output. It decreases light sensitivity of photoresistor, increase the output. The diagram as follows. They have a MCU, we're giving them the analog input, going to the voltage output. So where the light will be received to the LDR, the sensor. The sensor, the low light voltage will gives us a high output. Then the high light sensitivity will gives us the low output. So it is a photoresistor and gives us a photoelectric sensor. It is a device used to detect the distance, the absence of the project or presence of the project. So photoelectric sensor. We are using the light transmitter, often infrared or LED. We are using the light transmitter is one of the emitter, and they have another one is a detector. So the emitter emits the signal to the detector. If the detector detects the signal, we have no object value found. So first of all, we want to know the object are sensed by the sensors like a small, large, transparent, shine, static, and motion. They have these type of various conditions. The sensor can be easily works and senses. So distance equal to few mm to 100 mm. The photoelectric sensor they have measured the distance range of they have given that a few mm 1 mm to 100 mm. The light detected by the receiver. So this is a good diagram to explain the photoelectric sensor. So emitter will emit the signal and detector will detect the signal. So light will passes from the emitter to detector. If there is no object, sensor will not sense to here because there is no detection of object. So second one, when object present, the emitter lights will sense and detect did not receive the light because they have object. It can be senses. Through the beam method, this is a beam method and this is a refractive method. So the retroreflector is available. The emitter will transmit the signal. The retroreflector will reflect the signal to the detector. So when there is no object, they have a vice versa. If there is an object, the emitter will sense signal. The object will cut out signal to the detector. To have a object vision at the time, we will note down sensor will